So, hello, beautiful people. This is the second question in the top interview question series, and this question is a very famous question, which is कि we have to print a matrix in a spiral form. Like we have a matrix, we have to return a vector, 1D vector basically, which contains the spiral order of the matrix. What we mean by a spiral, it's basically a spring, like something like this. This. Like this is a very famous scene in movies, which basically when they hypnotize people, these are the signs. Like you. In this order, basically we have to print. We have to basically return the vector by inserting elements in this order. That's the question. This is a very famous interview question. I think this these kind of problems are generally asked in companies like Amazon and stuff. Okay, so this is the sample example. So we are first inserting 1 2 3, then 6 9, then 8 7, then 4 5. This is how we have to basically program this question, so that the answer vector will have elements in this kind of form. Okay, so how will we do this? If we look carefully, so there are four things which are changing here. Like this is a small example, let's take a big example. Okay, so this is the big example. So this. Let's suppose if we have a bigger example, let's suppose we have a 10 cross 10 matrix. Okay, let's suppose something like this. So first we'll do this, then we'll do this, then this will basically, from here on, from this to this we have one turn. After this we have another turn. From this to this, from this to this. So if we look carefully, so there are four things which are changing. The right hand side and the downward side are going inwards. The right hand side is going to left hand side, and the down, basically the bottommost side, is going upward. Similarly, the upward side here is going downward, and the leftmost side is going rightward. There are basically four things which are changing. So let's suppose if this is the y-axis, I'm denoting these two elements by sx and ex. Sx means starting x, and ex means simply ending x. Similarly, here sy means starting y, and ey means ending y. So when I'm going from here to here, so in this my sx point is constant. So first of all, sx ex are basically on the y-axis, and sy and ey are on the x-axis, so don't confuse. Okay, so here I'm iterating this. Basically I'm moving my eye from here to here, and I've fixed sx. My sx is fixed, but my eye is not. Right? What is eye? Eye is basically varying from sy to ey. So this will do this. This will print this. Now when I'll go this, in next turn my sx will increase. We have to do sx plus plus, so that it can print this row. But before this, I'm printing this row. So if for this row my ey is fixed, but my basically this will have ey fixed, but my I is varying from sx to ex. This is varying basically. These are the elements we have to print. So this I is varying from sx to ex, and this I was varying from previous I, sy to ey. This is sy to ey, and this I is sx to ex, ending x, starting x. Now when we are at this, in this my ex is fixed, but my I is again varying. Now this I is varying from ey to sy. Ey minus 1, because will start from the next element, and similarly this would be sx plus 1, not sx. This I is varying from sx plus 1 to ex. So now similarly this one second, let me just zoom it a bit. It's not zooming. Okay, cool, no problem. Now this will basically be, now this bottommost row will basically have ex fix and I would be varying from ey minus 1, from ey minus 1 to start y. Now after this we have to decrease ey minus minus after this, and after this we have to basically decrease ex minus minus. Similarly, now we'll start from ex minus 1 to start x plus 1, because we have to just go till here. We will basically vary this and we'll fix sy would be fixed here in the last. Similarly, one turn is done. After this one turn we have to basically again check if we can basically do this. If we can do this, we will do the same procedure. So what I'm going to do is I'm going to increment sx and sy, and I'm going to decrement ey and ex. I just have to check if start x is less than ex and the start y is less than equal to ey at every point. If it's not, then it means that we've already printed that element and we do not need to print that element again. That's the logic. So that's what I've coded. The code is fairly simple, but it requires a little bit of implementation skills. It's not very like short. It's decent amount of code. Okay, so if my matrix is, so I've just created a vector, let's call it ans. If my matrix size is 0, we just have to return ans. And I've created 4 pointers: start x, start y, end x, end y. Just similarly, just like in the problem which we had before. Now I've initialized start x, start y with 0 0 and end x, end y with matrix dot size minus 1 and matrix 0 dot size minus 1. I think it's fairly simple, fairly normal. Now till my start x is less than equal to end x and start y is equal to less than equal to end y, right? So what I'm going to do is, first I have to fix start x to print the uppermost row, then I have to fix end y to print the rightmost column, then basically I have to fix the bottommost row end x to print the bottommost row, and then I have to basically fix the starting the leftmost column, which is start y, to print the leftmost column. Okay, but there's one thing which you have to check again. So this is a little bit tricky. I got stuck here for like 5 minutes. So why this condition is necessary? Like if I'm checking this here, but why this is necessary? So there could be a point. So my question is that if I'm already checking this above, then why this if condition is necessary? Like what's the need of this if condition? So the thing is, here I'm not incrementing start x or I'm decrementing end y. So what could happen is ki there might be a chance that start x is equal to end x. After incrementing, start x has been equal to end x. It could be possible that start x and end x have become equal. Now in that case, I've already inserted the element in the vector in the previous two in previous two loops. I don't have to do it again. That can be the case. So let's say कि मैं ऐसे गया, I'm going like this, so this, like it could be possible that here if I'm not checked, so I can basically print this 9 again. I can print this 10 again, because while doing this two conditions, I'm not incrementing start x or incrementing end y. I'm doing this in the bottom. There could be better implementation, in which we can basically increment these or decrement these above. But what I want to say is कि I was not able to do that, so I did this. Now this condition is necessary because there might be a chance that I'm printing a repeated element. After this, it might be possible that all the spiral in the matrix, all the elements of the matrix has been covered. So I have to check again. If it's equal, it means that it has been covered, so it should be less than this. So this is why I've used this condition. Now in this I'm just printing the I think I'm clear. So in this I'm just printing the bottommost row, and in this I'm just printing the leftmost column. And after this whole process, after this whole four for loops, I'm just incrementing start pointers and decrementing end pointers. and after this I'm just basically return my answer. I'm just returning answer, basically returning the vector whose name is ans. That is the logic, and this is working 100% runtime. So this is the question. I hope I was able to explain these tricky conditions. If you did not get it, you can just check my code and you can understand by yourself that why I've written this condition. This is very intuitive. This is slightly not intuitive, this if condition. So that was the, yeah. But okay, to sum up, I'm using this condition because it might be possible that in the above two for loops, the elements could have been already been covered. It might be possible. So that's why this condition is is necessary basically. Yeah. So this is the code. You can check the code in the description. I have attached a link of this solution in the description. And yeah, thank you so much and have a good day, guys. Bye.